Hello everyone and welcome. In this video we're going to look at some applications of implicit differentiation. Specifically we want to plot this curve y cubed minus x minus y equals 1 and determine at what points the tangent line will be vertical. So as I'm trying to start this problem, the first thing I might want to do is just solve the equation for y. If I can solve it for y, I can use the plot command, I can calculate the derivative, and I can find the slope of the tangent line and go from there. So in this case I might start off by trying to solve y cubed minus x minus y equals 1 for y. But when I try to do that, you can see that I get a very complicated result. It turns out I can't take this equation, solve it for y, and express y as an explicit function of x. So that means I really have to treat this like an implicit equation. So I won't be able to just solve this and plot it. Instead, I'll have to visualize it using the contour plot command. So I can use contour plot, and then I can enter in my equation, making sure to use double equal signs, and then plot this over a range of x and y values. In this case, I'm going to plot it from -4 to 2 for my x range, and I'm going to plot it over a y range of -3 to 3. Alright, when I do that, I can see my curve here. And so in some physical problem, I might have a reason to want to identify where my tangent line goes vertical. It looks like it happens somewhere around this area and somewhere around this area, but I want to find those exact locations, those exact points. So if I can find an equation for the slope dy dx, then I should be able to find out when that value is undefined. So given my equation up here, how do I calculate dy dx? Well, I'll have to use implicit differentiation. So what I want to do is take the derivative of this with respect to x. Of course, when doing this with Mathematica, I have to make sure I tell Mathematica that y is a dependent variable and it depends on x. I'll do that for everywhere I see an y. So now that I've set up my command, I can run this, and I can see that I have calculated the derivative of this equation implicitly. And now what I like to do is solve for this y prime piece. So I can just wrap my solve command right around this derivative command, and I'm solving for y prime of x. And so when I run that, now I have an explicit formula for dy dx. It is this guy right here. And so if I plug in any value for y, I should be able to find the slope of the tangent line at that location on the curve. Now I'm specifically looking for when my tangent line will be vertical, which means my slope will be undefined. Well, that happens when the denominator here is equal to 0. So really what I want to do is I want to figure out when, I could do this by hand or by using the solve command, when this denominator value is equal to 0. I'm going to solve to figure out when, in this case, my y of x is going to make that true. And so now I have my two results. Turns out there are two y values that will lead to a vertical tangent line, an undefined slope, these two y values. Now, there's a couple ways I can pull out these results. One thing I could do is I could just define my first y value to be this guy, and I could really just copy and paste these guys in. And that is certainly a good approach. So I'll define a y1, I'll define a y2, and just store these y values. Okay. Now that I have my y values, I need to find the associated x values that will lead to the points where the tangent line is vertical. So how do I do that? Well, I have my original equation. That's going to look something like this guy right here. And now the idea is that if I plug in one of my y values, y1 for instance, like this, so that will be a known value, well then I want to figure out the associated x value. So basically I'd want to plug in my y1 and figure out the x value that would generate. And it looks like I'm going to get this value. That value was kind of complicated, so what I'm going to do is I'm going to put a decimal value in, and I'm going to generate that decimal value out. So then here is my x value. And once again, if I want, I could store this x value with the associated y value. So if I copy this guy and I set x1 equal to that, I can store that, and then I really have my first point that I'd be looking for. It would be the point x1 and y1. So now I have my first point where I believe the tangent line is vertical. Now what about my second point? Well, I'm basically going to repeat that same process, except now I want to work with y2. So I could just change my y1s to y2s, for instance, and run that guy, and I would find the associated x value with y2. I could then copy this value and store that one to an x2. Alright, and then my second point, my point 2, would be my x2 and my y2. That would be my second point. So now I believe I found the 2 points on that curve where the tangent line should be vertical. But of course I really want to verify that. So what I will do is I'll go back up to my curve. I'm just going to copy that whole line of code and just bring it right down to the bottom here. Here is my contour plot. And I would like to plot the 2 points that I like to work with here. So here's what I'm going to do. I'm going to use the command point, and that will generate points. And the 2 points that I want to generate are point 1 and point 2. Those are my 2 points. And so if I run this, it will establish the points, but it won't actually show me the points. Points are a graphic element. So to show what those look like, I will have to wrap the command graphics around that command. And so if I do that, I see the contour plot, and below it I will see a picture, an image of the 2 plots. Now I don't want those to be separate, I want them to be together. So now I have to do is just show both of these things together. Show with the first contour plot as the first argument of show, and then I'll throw in a comma, and the graphic will be the second argument of show. And so lastly, I'll just close that show command, and now I have a curve with my 2 points, and sure enough, those really do look like they're at the points where the tangent line is vertical. Alright, so what did we do? Let's recap the big ideas. First, I tried to solve the equation for y and realized that I couldn't. I really had to use implicit differentiation for this problem. Then I used contour plot to generate a curve, even though I couldn't solve for y. After that, I took the derivative implicitly of my equation, making sure that everywhere I saw y, I used y of x to show that dependency. And then once I took the derivative implicitly, I solved for my y prime. That gave me my equation for y prime. If I want to find out where the slope is undefined, I looked at the denominator and found all the values, made the denominator equal to 0. Once I had those y values, I plugged them back into the equation to find the associated x values, and that gave me my points. And then I was able to plot all that content together. Alright, that concludes this video on applications. Thank you.